Mean, another word for it, sorry, is average. So for instance, if you're looking at the statistics of a basketball player, which if you ever watch ESPN or any of those sports shows, it's all math, it's all statistics. You know, so-and-so on average plays, you know, scores 10 more points during home games than they do travel games or something like that. So if you were asked, what's the average, what are the average amount of points that player received in the last 5 games, you would add up all their points for the last 5 games and divide by the number of games. Add up and divide by how many. So whenever it says definition or description, I would always try to put it in your own words. Add up and divide by how many. So if I had, again, those scores of 15, 20, and 10, I would add these up, 15 plus 20 plus 10, and divide by how many games there are, 3. And that would find me the average. So let's see, 25 plus 20 is 45 divided by 3. So he averages 15 points a game. Okay, so that's the average. The median is the middle. And how you do these, you put them in order. I know that my handwriting's not very good. Cross out. Yeah, it doesn't change the font size. Cross out. Cross out until you get to the middle. So a lot of these, I'm writing this here very quickly and very informally because I want you to write it in your own words. But the idea of this one is if I have, you know, I'm going to put them in order. Let's say it's over 5 games. He only got 2 points one game. Then he got those 10 points. Then he got 12 points a different game. Then he got 15 points. Then he got 20 points. Finding a median is when you cross out the smallest, then the biggest, and then keep going in order to find the middle. So median's the middle number. Okay, for the mode, think of M-O, most, frequent. It just means the one you see the most. Number you see most. So in the case of the one I just did, there was no mode. But let's say in the 6th game, 1, 2, 3, 4, 5, he scored 12 points again. So the data would be 2, 10, 12, another 12. Because the 6th game, he gets 12 again. Notice I'm putting them in order. Well, the mode would be 12, because that's the one that we see the most.
By how many of them I have. It looks like I have a total of 9. Now you may have to use a calculator if you have lots of different data points, but that's okay. When I added everything up, I got a total of 74 divided by 9. Now oftentimes, it's good to take this all the way out to a decimal. I got 0.9135.
Find the median. What I like to do is cross off, and I like to make one side go like this and one side go like this just so that I know. So until I find the middle. Pretty familiar with. So we have 2 numbers left over, but they're both 15. So in this case, our median is going to be 15. Okay, really quickly before I erase. So in this case, the biggest number is 18. The smallest number is 12. Difference means subtract. So our range is 6.
Stats. Okay, cool. So standard deviation, we're going to use this one. And don't forget all the other things we need are in here too, except for mode. But mode you should be fine with, right? Because it's just the most frequent. So you just find the number that's there the most. Here's your mean. Here's your median. The minimum and maximum, if you can't see what the largest and smallest numbers are, those are there for you to find the range. And here is combinations, permutations, and standard deviation. That's what we're going to need. So first of all, I click on the one they called mean. You can even type the word mean. And then the data is what you put in there with commas. You don't have to put them in order or anything. It will do that for you. So that's the mean. That's what's going to go right in the middle of your bell curve. And the standard deviation is going to be the average distance from the mean. So all I have to do, honestly, is what I do at least, is copy this, paste it, and then change this to standard deviation. There it is. So that's what goes in the middle, and this is what you're going to use to find either side. And the next part says draw the bell curve. So this is the part where I literally, and this is my guide for everything. This guy right here, page 3. There it is. So that's what I'm kind of sketching. I'm also looking at, this is the one other reason that standard deviation is nice is within one standard deviation, that's 68% of your data. That's a lot. That's quite a bit. So that the other parts of the data that are outside of that, the further it gets away from the mean, the more rare it is, which is why over here is super rare. But the mean goes right here. And then the standard deviation, one standard deviation from the mean on either side, 2 standard deviations on either side, 3 standard deviations on either side. And what we're doing here is putting the mean there, and then you're going to add 9.5 here, and then again for 3 standard deviations away from the mean. And then from that 41.7, subtract 9.5, subtract 9.5, subtract 9.5. So 41.7 plus 9.5, 51.2. So we'll do this in steps. So again, I'm doing this with my pad, which is not the best. 51.2. Then you add 9.5 to that again. That's 2 standard deviations away from the mean. Oop, not 95. 60.7. And then one more time. 20.2. And then for the other way, you're taking 41.7 and subtracting 9.5 3 times. $32.2. And this is words per minute. Someone can type. Minus 9.5 again, because I'm just subtracting another standard deviation away from the mean and labeling those main points that are important from that page 3. We call it the empirical rule of how that data spreads, knowing the standard deviation. And last but not least, 13.2. Okay, so now that's the bell curve. So again, remember the most important numbers I needed were the mean, which is the 41.7. The standard deviation was that 9.5. And then I added 9.5 each time for each standard deviation to go above the mean, and then subtracted 3 times to go below the mean. So now, again, I apologize, between the video I'm currently making and this one, you've got 2 examples of me doing this, which is plenty for the test. Based on this data, if you type 60 words per minute, you would type faster than about what % of the population? So here's where I'm focusing. 60 is around here. I want to know this percentage over here. So let's see. Based on this data, if you were to type 60 words per minute, you would type faster than about what percent of the population? Page 4. Because where that was at, let's see, this is 1 standard deviation away, that's 2. That's where the 60 was. So you could either add all these up or think about it as 100% minus 2.5%. So 100 minus 2 is 98, so 97.5. Depending on how people round, it might be 97.68, but that is what they're asking you to do. You're using that legitimately a lot while you're working on these problems. So 97%. And again, you may see different ones that are really close to that number. It really depends which one you're using.